Now let's look for a moment at a pressure versus time plot. Without going into the laws of flow, we can state that if we open a well to production at a reasonably constant flow rate, the flowing bottom hole pressure, P sub Wf, will soon stabilize. The stabilized pressure drop is called the drawdown. Note in this case that for a stabilized pressure of P sub Wf1, the flow rate is Q sub 1. If the flow rate is a higher value, say Q sub 2, the stabilized wellbore flowing pressure will drop to P sub Wf2. By testing a well in this manner, it is possible to estimate and plot its bottom hole flowing pressure versus production rate for any given average reservoir pressure. We see such a curve with the two data points for our two flow rates here. This curve is called the inflow performance relationship, or IPR curve. Because the reservoir pressure usually decreases as more fluids are produced, the IPR over the life of a well will shrink toward the origin. This family of curves, then, shows how a well's potential to produce at any given bottom hole pressure decreases with declining reservoir pressure. Note that if the flowing bottom hole pressure is held constant as the average reservoir pressure drops, a well's production rate will decrease until it no longer flows. Alternatively, if the flow rate is to be held constant, the bottom hole flowing pressure must drop continuously to maintain the flow rate. At some point, the pressure cannot be reduced any further, and the rate must drop.
The inflow performance relationship is a unique description of the performance potential of an oil well. It is the basis for the analysis of a well's behavior. It tells us what flow rate the reservoir will provide at a given pressure.